It concludes that division is not associative for whole numbers. Let us see the associative property of operations on integers. Under addition operation, it states that the sum of three integers is the same if the order in which their sum is changed. For example, 5 plus of minus 6 plus 4 is same even though if there exists change in orders. It concludes that addition is associative for integers. Under subtraction, it states that the difference of three integers is not same if the order in which their difference is changed. For example, 5 minus of 6 minus 4 is not same as 5 minus 6 of minus 4. It concludes that subtraction is not associative for integers. Under multiplication, it states that the product of three integers remain the same even if the grouping of the numbers is changed. For example, product of 4 minus 1 and minus 3 is same even if there is change in their order. It concludes that multiplication is associative for integers. Under division, it states that the quotient obtained by the division of three integers is not the same if the order of the numbers is changed. For example, when 10 is divided with 2 by minus 5, we get minus 25. And when 10 by 2 is divided with minus 5, we get as minus 1. So, minus 25 is not equal to minus 1. It concludes that division is not associative for integers. Let us see the associative property of operations on rational numbers. Under addition operation, it states that the sum of three rational numbers is the same if the order in which their addition is changed. Its example is as shown on the screen. It concludes that addition is associative for rational numbers. Under subtraction, it states that the difference of three rational numbers is not same if the order in which their difference is changed. Its example is as shown on the screen. It concludes that subtraction is not associative for rational numbers. Under multiplication, it states that the product of three rational numbers remains the same even if the grouping of the numbers is changed. Its example is as shown on the screen. It concludes that multiplication is associative for rational numbers. Under division, it states that the quotient obtained by the division of three integers is not the same if the order of the division is changed. Its example is as shown on the screen. It concludes that division is not associative for rational numbers. For addition, a plus of b plus c is equal to a plus b plus c for any three rational numbers a, b, and c. That is, for all a, b, c belongs to Q. A plus of b plus c is equal to a plus b plus c. For multiplication, a into b into c is equal to a into b into c for any three rational numbers a, b, and c. That is, for all a, b, c belongs to Q. A into b into c is equal to a into b into c. Let us do an activity on associative property. Click on the boxes which satisfy the associative property for different types of numbers. Let us do an activity on rational numbers. Drag the suitable answer from Group B for Group A and drop it in boxes provided against A. Let us do a lab activity on multiplication and division of rational numbers. Click each tab to know more. The objective of this activity is to understand how to multiply and divide the rational numbers and solve problems based on multiplication and division of rational numbers. The materials required for this activity are strips of paper, a pencil, color pens, and a chocolate bar. Let us see the procedure to find the product of 1 by 4 and 1 by 3. Take the chocolate bar and represent it as one unit. Divide the bar into 4 equal parts vertically. One part of it represents 1 by 4. Then divide each fourth into 3 equal parts horizontally as shown. Here one part of the horizontal division represents 1 by 3. There will be 12 equal sized pieces and one piece represents 1 by 12, that is 1 by 3 of 1 by 4. Let us see the procedure to find the division of 4 by 5 when divided with 1 by 2. Take the strip of paper and divide it into 5 equal parts and shade 4 parts. Now, divide each of 4 shaded parts into halves as shown. As there are 5 parts, each part represents 1 by 5. The 4 shaded parts represent 4 by 5. As further, the 4 shaded parts are divided into halves, which represent 8 subparts out of 5 original parts. That is 4 by 5 divided by 1 by 2, which is equal to 8 by 5. Let us answer the following questions. Shruti made 8 sandwiches for some street children. She has cut each sandwich into 4 triangular pieces. If one child can take only one piece, how many children can she feed? Procedure to answer the above question is as follows. Take 8 square-shaped sandwiches. Divide each sandwich into 4 equal parts as shown. Since there are 4 fourths in one sandwich, there will be 4 into 8 equal to 32 triangular pieces, and hence 32 children will be fed. A pizza is divided into 10 equal parts. Raghu had 1 by 2 of 3 by 5 of the pizza. What whole part did Raghu have? Procedure to answer the above question is as follows. Take the pizza, divide it into 10 equal slices as shown. Then consider 5 slices of pizza from the total 10 slices. Now, out of 5 slices of pizza, consider 3 slices. So 1 by 2 into 3 by 5 is equal to 3 by 10. So, Raghu had 3 by 10 of the whole pizza. From the above activity, we observe that to multiply rational number in fraction form, simply multiply the numerators and denominators, that is a by b into c by d, is equal to AC by BD, where B and D are not equal to 0. To divide rational number in fraction form, take the reciprocal of the second fraction and multiply it by the first fraction. That is, A by B. When divided with C by D, we get A by B into D by C, which is equal to AD by BC, where B, C, and D are not equal to 0.